Hello everyone. I, Mrs. Prapti Desai, lecturer, RMPS Balchandra Institute of Pharmacy, Khanapur, District Pune, deliver the presentation on size reduction. The learning objectives are: after completion of this presentation, learners will be able to learn or understand the concept of size reduction, importance of size reduction in pharmacy, and factors affecting on size reduction. So first we see the definition of size reduction. It is the process of reducing drugs into smaller pieces, coarse particle or fine powder. Second one is the importance. First, to increase the rate of solution. In case of chemical substances, because of reduction of particle size increases surface area for the action of solvent. To allow the rapid penetration of the solvent in case of crude drugs for extraction of active constituent from vegetable and animal drug. To get a uniform powder, because of particle size reduction, it helps in uniform mixing of drugs required for preparing different formulation for administration. Next one, to improve the stability in certain pharmaceutical dosage form such as suspension, the rate of sedimentation decrease to a large extent by reducing the particle size of drug. After the learning the importance of particle size reduction in pharmacy, here necessary to think about what are the factors which can be the effect on the size reduction. So pause the video, write your answer in your notebook. After that, play the video. So here is your answer. The different factors which are affecting on size reduction. First is hardness. So it is easier to break soft material to a small size than hard material. Second, toughness. The crude drugs or fibrous nature or those having higher moisture content are generally tough in nature. A soft but tough material may present more problem in size reduction than a hard or brittle substances. Stickiness. Stickiness causes lot of difficulty in size reduction. Next, material structure. Materials which show the some special structures may cause problem during size reduction. That is, vegetable drug which have cellular structure generally produce long fibrous particle on its size reduction. Similarly, a mineral substances having lines of weakness produces flake-like particle on its size reduction. Next, moisture content. The presence of moisture in the material influences number of its properties such as hardness, toughness or stickiness, which is its turn affects the particle size reduction. The material should be either dry or the wet. It should not be damp. The material having 5% moisture in case of dry grinding and 50% of moisture in wet grinding does not create any problem. Next one is the softening temperature. Waxy substances such as stearic acid or the drugs containing oils or fats become softened during the size reduction processes. If heat is generated, this can be avoided by cooling the mill. Next one, purity required. Various mills used for size reduction often causes the grinding surface to wear off and thus impurities come in the powder. If a high degree of purity is required, such mills must be avoided. Moreover, The mill should be thoroughly cleansed between batches of different materials in order to maintain the purity. Next one is a physiological effect. Some drugs are very potent during their particle size reduction. In a meal, dust is produced which have the an effect on the operator. In such cases, enclosed meals may be used to avoid dust. Next, ratio of feed size to product size. To get a fine powder in a meal, it is required that fairly small feed size should be used. Hence, it is necessary to carry out the size reduction process in several stages using different equipments, that is, preliminary crushing followed by coarse powder and then fine grinding. Next, bulk density. The output of size reduction of material in the machine depends upon the bulk density of the substance. Next, methods of size reduction. There is the first combined impact and attrition, cutting, compression, and the impact. Here are the few mills. Those are working on this mechanism. The first is the ball mill, which is working on combined impact and attrition. Second mill is the cutter mill, which is mechanism is the cutting. Third mill is the roller mill, the mechanism including compression. And the fourth one is the hammer mill, in that the mechanism involved is the impact. So this is overall about the presentation. Thank you. Thanks a lot. Thank you.